Hey, today we will briefly talk about how we brought our latest game, Old Man's Journey, to Nintendo Switch with only a team of 2, and how we on the way implemented a pointer-based game. Let me first introduce ourselves shortly. This is Jan, and I'm Josef. We are part of a small Viennese indie game studio called Broken Rules. We have been around since 2009 and have worked on games like And Yet It Moves, Secrets of Reticon and Chasing Aurora. We have released games to Nintendo consoles back to the original Wii. Our second game, Chasing Aurora, was even a Wii U launch title. And we brought some other companies' games also over to Wii U, like Guacamelee, Black, and Electronic Superjoy. But today we are here to talk in particular about our latest endeavor, Old Man's Journey. So, our game tells a story about an old man who goes on a burdensome journey and reminisces about his past during this trip. He remembers defining moments and decisions he made in his life. Some of them are really happy and joyful. Some of them are full of regrets and sadness. With our games, or with this game in particular, we tried to portray a full spectrum of emotions because that's what our lives are made up of. With Old Man's Journey, we made a short narrative-driven adventure with very high production values. The gameplay itself is actually quite simple. You can shape the landscape and form intersections, and the old man can jump between the layers at these intersections to advance. But in between, he has to rest from time to time because he isn't the youngest man anymore. At these resting places, the old man shares emotions and memories about important moments of his life. Through these moments, the player gets to know him and his motivation more and more as the game progresses. Let me quickly introduce the team behind Old Man's Journey. The core idea and vision of the game came from Felix and Clemens over at Broken Rule. They were supported by Jan, who is standing next to me, Brian Main, Stefan Kerniak, and by our friends at Salon Alpine, who helped drive the visual aesthetics of the memories. The music and sound design comes from Andrew Rohrman, aka Scientific. During the development of Old Man's Journey, because it came first on iOS, Android, and Steam, Nintendo announced their new hybrid console, Nintendo Switch. We really liked the concept and overall the hardware and its possible range of input methods. So we decided, after the initial release, to bring it over to Nintendo Switch. At this point, let me hand over to Jan, who will take you all on a deeper dive into how the game works in more detail, especially from a coding and technical side of view.
Okay, so hello everyone. As Josef said, I worked more on the implementation sides of things for this project. And one of the core aspects about the game that we had to adapt for the Switch was how the interaction or how the input worked. Our preconditions were that we were coming from mobile and PC. So the core interaction evolved around moving a pointer, clicking and tapping, and dragging things around, similar to an adventure game. You can also see that in the video. And basically all interaction in the game is a combination of these few properties. So you need to know the position of the pointer, you need to know if it's clicked, if the click has just started or stopped, like you would query from the input class, like get button down, get button up, and these things. The game was designed to work with single touch, but it was also supposed to handle multiple touches. For tablets or smartphones. And you can see in the video that you can shape both hills at the same time, but it's not essential for gameplay. So we needed it to work with a single touch as well, or with a click on PC. So there were no gestures or like swiping or pinching involved. So the first thing when we sort of how do we realize this on the Switch? Because coming from mobile, the performance was mostly optimized. Only a few bits where we had to optimize a bit more. But the biggest challenge for the project was the new input capabilities. Also the part I was looking forward to the most, because I always like to implement input stuff. So here we suddenly have no cursor, and we kind of have touch, because when you play in handheld mode, you can use the touch screen. But as soon as you dock the console, you have no way of touch input. So the game as it was played before could not be played as that on the Switch. So we had to find some way for that. And we really see the flexibility of the Switch as a real strength of the console. So it's like this on-the-fly docking, undocking, using the Joy-Cons and whatever. And we really wanted to support that as well as possible in all the different play modes. So you have the handheld mode, and there you have touch. But then you have the tabletop mode, which is when you undock the Joy-Cons, and the console stands on the table. And then you have TV mode, where you just play it on your projector or your TV. Also with the Joy-Cons detached, or with a Pro controller, for example. And for this version, or for this style of playing the game, we wanted to use the Joy-Cons kind of like a pointing device, like the Wiimotes were at the Wii or the Wii U. And for all setups, we wanted to be able to use the analog sticks and buttons for moving a virtual cursor around and clicking. And it started out as like, let's try how that works. And in the end, it was working way better than we expected. So it's not just a gimmick, or not that we also support that. So it really makes sense to play this game as well like this. Because the game supports multi-touch, it can also be, or could also be played cooperatively. We saw that happen with people playing on iPads or on tablets, that they suddenly started to work together and really enjoyed that kind of playing. So be it parents with children, or friends, or a couple, or whatever. And that, from watching, that felt really nice, and we wanted to bring that experience over to the Switch as well. So we decided to have multiple players being able to play the game, or basically 2 players. At the same time, we wanted to have a seamless transition between the various input methods the Switch offers and that we wanted to support. So, for example, if you play in handheld mode and you use the touch controls or the touch screen, you can, at any point of time, just use the analog stick and the buttons, and you would not even notice that there's a different system behind driving that. So you would never have a dialogue or some options where you have to get into. We wanted to make that really seamless. And also had to make sure, of course, that these input methods are not in the way of each other, of course. We already used Unity's event system from the beginning, because it's a very good way to handle multiple interactions at the same time. So, of course, for the smartphone and for the tablet version, we handled multi-touch for that. And the system is it's built in Unity, and it's coming from the new UI system. So all the UI interactions with the new buttons and new features, basically in the core it uses this system. But you can also attach a physics raycaster to it, and have colliders on the object that have the same collision mask, and then you can also interact with objects inside your game world. I think not a lot of people know this, or people are often surprised when I tell them this. And this is a really powerful tool, and we use that for the whole game, actually. So how to do it on the gameplay side is you have an object, you attach a component to it that implements interfaces from this event system. So, for example, an I-pointer-click handler or an I-drag handler, and it forces you to implement some callback functions that the event system will invoke later on. So, yeah, like on pointer down and so on. And inside there is basically all our game logic. Yeah, so what happens if you click on something and stuff like that. The advantage of doing things like this is that it really decouples the actual input events, like on pointer click or on drag or whatever, from the actual input devices that the player uses. So, so these are like really two separated corners of the code base, which is awesome because for the Switch version, we didn't have to touch the game code at all. So we just had to extend this input system in a way that it feeds this, the event system, and everything worked as expected and as it worked before. The source code to this event system is totally open, so it's totally open source. You can find that on Unity's Bitbucket, and it's intended to be extended. You can also completely replace it because it comes with Unity also. And yeah, and how the system works is it analyzes your actions with the pointers. It generates like a pointer event and sends that to your callback functions. And these pointer events provide you with the position on the screen where the interaction happened. Each pointer has a unique ID to them so that you don't mix the two. Like if there are two happening at the same time, you know those two separate ones. And from the context of what function is called, and also from the other fields the pointer event struct provides, you can know if the pointer was pressed, or it was just pressed, or just released. To make that work with all the different input methods of the Switch, I decided to go for this route. So we have this. Basically, the event system consists of three components, or like three elements. There's one, the event system itself, and out of the box, it only can handle one input module that makes the raycasting and tracks the object over time. So I wanted to extend that to support multiple input modules, so we could have it's like one input module per device class, basically. So like one for touch, one for the sticks plus buttons version, and one for motion control. And each of this module can support in our case, 1 or 2 pointers, but up to how many you ever need. So you can do like really crazy things with that. So yeah, and as I said, per player, per input class, there is like one object handling the actual querying from the devices. So this is all you basically in the end have to implement to support a new device. You have just to tell which position it is currently on the screen, and that could be some fake input or like the button controls that move relatively, and then the button states. So the first module that we used is for touch and for in handheld or in tabletop mode. And it just uses the standalone input module that comes with Unity. And it works out of the box with the Switch. So that was awesome because the first input method worked just when we started it up the first time on our dev kit, which was awesome. The second one is the virtual cursor thing, where you have like gamepads, be it the console itself in handheld mode, or when you play with Pro controllers. There you use the analog stick to push the pointer relatively around, and you use the buttons to simulate the click, basically. And then number 3 is if you detach the Joy-Cons from the console, then you play either in TV or in tabletop mode. And we implemented motion controls and calculated the position of the pointer on the screen every update. So you interact like with a laser pointer, or like you would have with the Wiimote on the Wii or the Wii U. Again, you use buttons for clicking. But for this method, we also needed one more button to recenter the cursor from time to time. That's necessary because out of the box, the Switch doesn't offer you a pointer, as I said before. So you kind of have to get around that problem. Maybe some of you have already done this or know this. When you have a gyroscope and an accelerometer, as the Joy-Cons do, you basically have an inertial measurement unit, or an IMU, which is basically just fancy for you could track the device's orientation. But that all works relatively, so the device has no clue of where the TV is. So in the calibration process, you first put the device down, so the sensors are at rest, and once that happens, or once that happened, you basically tell the Joy-Con or the game where the center of the screen is. So you point at it and press the reset button. And from there on, you have relative movement according to the movement of your hand. And that works really smoothly. So Still, with the IMU, you have some drift that you have to account for. It can correct drift in this axis and also on this one, but not horizontally, because you would need to have a magnetometer for that. So what happens after some playing time, that the pointer is a little bit offset to the left or to the right, but you basically just point to the center of the screen again, press the button, and you're fine to go. But this is something you have to understand when you're working with the Switch, that this is how you would have to do pointing controls. So one thing I wanted to dive into real quick was how we actually doing this resetting, because it's not super complicated, but it took me a while, and I wanted to give you a shortcut if you plan to do that. So the Nintendo Switch plugin for Unity already provides you with a device orientation per Joy-Con or per device. So you get that for free, basically. And whenever the reset button is pressed, I look at the current orientation of the Joy-Con. Then I calculate the look direction or the look rotation, which is basically on these two axes. I don't care about this one. This is what the code in the middle does. And then I multiply this offset with the actual Joy-Con's rotation, and you just have a nicely centered relative motion from there on. That works really good, and it's really simple if you know how to do it. So a short recap on the technical side. What went well? So it was really awesome to have the game code separated from the actual Switch-specific code or the device-specific code specifically. So it was really nice. We didn't have to touch any of the game code. It just worked as before. And there is this separate kind of code in the other corner that steered all the input events. And yeah, that was good. Also having these multiple input schemes that were well separated was really good, because we could add a new one, disable one, and also be back compatible to the other platforms like the mobile devices or PC, because we just can completely ignore what they are saying, like these input modules. It's also easier to extend to new devices. A short fun fact from development, I kind of hacked in Pro Controller support in the last minute, and it was like a work of 1 or 2 hours, because the system itself was set up in a way that it was really easy to put in another device like that. And it just worked, which was awesome. What went, well, not so well? The whole event system, there's like a huge layer of abstraction. So if you want to dive into it and want to understand how it works internally, which at least for some parts you have if you want to extend it, it's a bit hard to understand at first. But you can get used to it. And as you said, you have all the source code, so that helps. It was a bit of a bummer that it only supported one input module at a time, but it wasn't too hard to extend it to support multiple. But I was a bit surprised by that. So like one input module would override the other one, so they deactivate each other on every update. This was not what we wanted to have. And all the input is like object-based, like game object-based. So if for some reason we wanted to know the cursor position at some point from some random code, we had to actually store the current pointer position somewhere else and cache that, which it's not too complicated, but it's an additional step needed to do, and I had an additional input manager just caching all these pointer states. But yeah, other than that, it worked smoothly and was a nice ride. So finally, I will hand over to Josef, who will give you some more insights about how the management worked and how we were able to ship a game on the Switch with a team of just us two, basically.
Thanks. Being such a small team, in our case only a team of two, it was at first quite difficult to plan all the different things and tasks you have to do on a console. But from our experience from developing games for Nintendo consoles before, it was quite easy to identify the tasks. So this was not the problem there. We also knew back from Wii U what it means to launch a game on a console that is quite new to the market. So that was also not the difficult part. But in our case, the small team size was quite a challenge this time around. In the end, we decided that Jan should almost exclusively handle the coding side of things, and I would do all the overhead. That means like planning, getting ratings and localizations done, communicating with Nintendo, doing all the back-end work, doing PR, sending out press keys, and also be the one and only QA. For some things like design and submission, we joined forces again and helped each other out quite a bit. I tried to show this in the slide. So the white panels are the areas that Jan was dedicated to, or they were dedicated to Jan. The black ones are mine, and the gray ones are the ones we shared somehow. There are some pluses on some of the panels. The white pluses on design and store assets mean that Clemens and Felix helped us a bit, and the pink plus on rating zero means that that was the only task we couldn't do ourselves, and we had some help from outside of Broken Rules. So why did we need help there on this zero rating? So it was our very first attempt releasing one of our games on a console in Japan, and we really wanted to do it by ourselves, and we didn't want to offer rev share in exchange for maybe hiring a publisher. So we really wanted to do it by ourselves. And at first, this was quite an uphill struggle. So, but we managed to do it in the end. But we managed to do it with some help from outside. We had a partner in China and also in Japan with Tilt Games Asia, and they helped us already on the mobile version of Old Man's Journey, and they acted as some kind of relay between the rating agency and ourselves, and they could speak Japanese, of course, because we couldn't. And with their help, finally, we did get the Japanese rating quite quickly. Nintendo of Japan and its employees, so all the communication with Nintendo of Japan and its employees was also in Japanese. I tried to solve that with Google Translate, I have to admit. And it worked out, but it only worked out because the guys over at Nintendo of Japan were really super patient and helpful. And if I didn't get something on the first try, it wasn't that kind of a problem. So was it worth bringing Old Man's Journey to Japan for Switch? It definitely was. As you can see here, Japan made up quite a large chunk of the overall sales on Switch, so definitely worth it. Was Nintendo Switch a success for us as a studio and as a team? That's kind of another question. Success is always really hard to define, and it differs on who you ask. But for us personally, it was a success on many levels. Commercially, first it was. Pre-order and launch went very well. Old Man's Journey on Switch was able to recoup its porting costs in only 6 days after launch, so that was quite good. And we are seeing very healthy sales since then. The porting process itself was easy and straightforward because Nintendo and Unity did a really good job of streamlining the process for small teams like us. But maybe also important was that we had a lot of good times bringing Old Man's Journey over. So I think in such a small team, it's really crucial that that the temperaments and the skill sets, they match and complement each other. And luckily, Jan and mine did in some way, or they did quite well. We tried a lot working together, grew very fond of each other as colleagues, and I think we even grew closer as friends in the end. We were not sure to include this more personal part here, but we decided to do so in the end because we think it's really important to be mentioned as part of the success story of the port and of Old Man's Journey in general. So, looking into the future, we built up a lot of know-how for how to bring projects successfully to Nintendo Switch, even to the Japanese market. So if you outside there have a game you want to bring over, feel free to get in touch and we can start a conversation, of course. Thank you all for listening and coming by. You can always follow us on Twitter if you want to stay up to date. If you have any questions right now, feel free to ask. Please go to the microphones over there. And we will be at the Nintendo booth right next. They will show, there you can play Old Man's Journey on 3 stations there. And if you want to have a personal chat, let's just meet outside there. So thanks again.
Yeah. Thank you. Nice. Cool.